Let us see the fifth subdivision of the first problem. On the set of natural numbers, so it is to be underlined, on the set of natural numbers, the relation are defined by x related to y if x plus 2y equal to 1. Okay, so we should have for x and y all the natural numbers only. Okay, so natural number we know that start with 1. So it will go on 1, 2, etc. Suppose if we substitute x equal to 1 and y equal to 1, what will be the answer? 1. If we take x equal to 1, y equal to 1, 1 plus 2, which is not equal to 1. Okay, so if we choose the set of all natural numbers, this relation is not true. So or the relation or the set is an empty set. So there is no choice of x and y to be true with this. Okay, so what is it is true or not, it is asked. Okay, now it is not reflexive because here we cannot find any number satisfying this one. So it is not reflexive. Next one, it is symmetric. Why it is symmetric means, so if we choose any number for x, so the reverse order will be true for y. So it is true. Third one, it is transitive. So if we choose any three numbers x, y, z, so that is also true. Okay. Now let us go for the second problem. Let x be the set having 4 elements here. So then R be the ordered pairs having only these 3 possibilities, that is a, b, b and a, c. Okay, now we are going to write down the minimum number of ordered pairs to be included to R to make it all the 4 relations. Okay, so what is reflexive property? What are all to be included here? We have to include minimum number of ordered pairs only. Okay, we find here there are 4 numbers, 4 elements a, b, c and d. What is reflexive? A should be there, b, b, c, c and d should be there. Let us check whether all these pairs are present here. Only a and b are present. The rest of the 2 are absent here. So what are all the 2 things we have to add here? Minimum pairs c, c and d, d to make it reflexive. Okay, now we go to symmetric. So let us check here. Only we have to check the given R elements. So a, b, it is reflexive. So for a, c, what is its symmetric element? C, e. That is to be included. We need to add a minimum number, that is the most important. So we have to check with the given R elements only. Now transitive. Transitive means what it is given? It is a, c, but we should find c, b something, then only we can include. So transitive, here we cannot include nothing to satisfy the transitive relation. So how this equivalence relation is satisfied or not? What is an equivalence relation? If all these 3 relations are satisfied, then only this R is called an equivalence relation. Here transitivity is not satisfied, so we cannot say that it is an R is an equivalence relation. So it is not an equivalence relation. Let us move on to the next problem. So here we are given only 3 elements and your R is a set of all the same set of elements as the previous problem, a, b, b and a, c. Now here also we have to find the minimum number of ordered pairs to be included to make it reflexive, symmetric, transitive and to check with the equivalence relation. Here we have only 3 elements, so already 2 pairs are equal pairs are there, What is the missed pair here to make it as reflexive? Yes, it is C comma C. It is enough. If we include C comma C, then this relation is a reflexive relation. Then next we move on to symmetric relation. What is a relation given here? A comma C is given. What is its symmetric relation? Symmetric element C comma A. So this should be included to make it symmetric. As we defined above, for transitive, nothing can be included. So transitivity is not true. So since any one of the property is not satisfied, then we cannot call this as an equivalence relation. So since transitivity is not satisfied, so this R is not an equivalence relation. Yes.